Welcome to chapter 1.5. The first thing that we're going to tackle here is solving a formula for one variable. More commonly, if you recognize, here's perimeter of a rectangle or volume of a sphere. We might have situations where we need to figure out, well, if we have a certain volume, what does our radius need to be? Or if we have a perimeter and a width, what does our length need to be, right? You're trying to solve for one of these that your formula isn't given in, and it just allows you to have more versatility when you have a formula, or you Google and you find a formula. Well, it's not in the form that you want it in. What do you do? And that's what we do when we solve for a variable other than the one that it's presented in. Or, in this case, because we do have a lot of these reciprocal relationships in nature, right? This is not stated in terms of any of them. None of these. Because the relationship isn't like that. It's not a direct relationship. It's a reciprocal one. So what do we do if we have two of them and we need to find the third? So that's what I'll walk you through here. Of course, you could always plug in two numbers and then solve for the third, but as is the case with most formulas, if we can rewrite it in a certain way, those of you who are in science with me, number one, you can put that into an Excel spreadsheet, and then that will take care of all the calculations. If you have to do a whole bunch of them, it will do that for you. Or you can have that formula there and simply plug in the numbers you need and not have to, solve these three fractions every single time that you're looking for something. So what we'll do here basically is to cross-multiply, and for that we need a single fraction on this side, and that's what I showed you in class today. But there is a shortcut, and it is to multiply both sides by the least common denominator. You kind of saw that when we were simplifying compound fractions, those fractions that contained fractions in the numerator and the denominator, back in chapter 1.4. All right, so this is similar. So in this case, I'm going to multiply both sides by, and since these are all different, the least common denominator is simply going to be all three of them. So I'm going to multiply both sides by r, r1, r2, right, all three of those. So then the left side, the r's cancel out, and I simply have r1, r2. And then on this side, we'll distribute. So for the first term, r1 cancels out, and I have r2, plus over here r2 cancels out, and I have r1. Alright, so let's say, for this example, let's say I'm solving for r2. I want to state this relationship, but r2 in terms of the others. So for that, I want to bring all of my r2 terms over to one side. So I'm going to subtract r2 from this side and from this side. So that will give me r1, r2 minus r2 is equal to r1. And now I want to divide out everything that isn't r2. And to see that more clearly, let me factor out r2 from everything that isn't r2. Alright, so there's my first term, and then there's my second term, and that's equal to r1 still. Alright, now I can divide by r1 minus r. And you could have divided by r1 minus r here, It's just it's easier to see if I go ahead and factor that out. And I have my answer, which is that R2 is equal to RR1 over R1 minus R. Okay, so that's the nice thing. When we were simplifying fractions, we had to put those together. But when we are solving equations, the nice thing is that we can multiply one side by anything we want as long as we do the same thing to both sides. Right? You can't do that when you're simplifying. You have to multiply by something over something. You can multiply by 1. Right? If I take these two fractions here, I could multiply this by 2 over 2 and not change it. But I can't just multiply one side by 2 if I'm trying to simplify a fraction, because I'd be doubling it. But the nice thing about an equation, and we'll use this a lot, is I can multiply by anything I need to as long as I do the same thing to the other side. So here, if I want to get rid of these fractions, I can multiply by the least common denominator, which is BD, and I will get AD equals CB. Ah, you know, that's actually why cross multiplication works. AD equals CB. If you ever wondered, why does cross multiplying work? It is basically a shortcut for multiplying both sides by the least common denominator, because that's what you end up with. And that's what we're doing here. So that is the shortcut when it comes to working out a problem like this. The longer way that you saw in class today was, of course, to combine these two fractions on the right side into a single fraction. So that's, again, finding the least common denominator on this side, 1 over r. So now I got r2 plus r1 over my common denominator, and then I had to cross multiply here. But that's more work. So I commend to you this simpler method, which is which eliminates the step of having to combine that. Just go ahead and multiply. Look at your least common denominator for all of these and multiply both sides by that value.